This video is going to give you an introduction to polynomial division. When we do polynomial division, we are trying to simplify a rational expression in mathematics most of the time. As a procedure, what we do is we follow the steps of regular long division, just like long division with regular decimal numbers. But rather than having different digits, we're dealing with different terms in a polynomial. So let me give you an example. I'll first write out a rational expression, and then I'll show you how to write it and work through polynomial division using this rational expression. So let's do something like x cubed plus x divided by x plus 1. Okay? This example isn't going to come out particularly nice, but it's going to show you how you set up and execute polynomial division. When I look at this rational expression, I have the numerator and the denominator. If we wanted to read this out, we'd say x cubed plus x all divided by x plus 1. So x plus 1 is the divisor, that's the thing that we are dividing by, and x cubed plus x is the dividend, that's the thing that's being divided. If I want to set this up using polynomial division, I can set up a regular division bar, like I would as if I was in, second or third grade, just doing arithmetic with real numbers. We put our divisor on the outside of the division bar, and we put our dividend inside the division bar. One thing that's really important with polynomial division is to include any terms that might be missing. So I have a cubic polynomial, this x is raised to the third power, and I have an x term here, but I don't have an x squared term. When I write down and set up the problem for polynomial division, I want to include an x squared term in case one comes out during the process of division. So I'll take all of the pieces that I have. I have an x cubed, and I have an x. I have 1x cubed and 1x. I don't have any x squareds, but I'm including a place for them anyway. Okay? And then I don't have any constant terms, but I'll include a place for them anyway. This is something that's new to polynomial division. You don't have to do it in regular long division because we use zeros as placeholders in a decimal number. When we have a polynomial, though, if we're missing a term, we usually just leave it out. So when we're doing polynomial division, include one spot for every power of the polynomial that you're dealing with, even if there aren't any of those terms appearing in the polynomial that's being divided. Okay? All right, now we proceed by following the regular steps for division. So we kind of work our way down through the number, dividing out different pieces as we go. The way that we perform our first step is to look at the leading term in our divisor and think about multiplying this divisor by whatever is necessary to eliminate the first term that we're dividing out of. So I need to think about what I need to multiply x by to turn it into 1x cubed. Okay? What I would need to do would be to multiply by, say, x squared. That would turn x into an x cubed. So I take this divisor, I multiply by the necessary term, which in this case is just an x squared, and I'll write that up here. I'll even line it up with my x squared column. So I had to multiply this by x squared, all right? And then I'll write down the result, this divisor times x squared, below my dividend. Okay? Once I've done that, what I want to do is I want to subtract this polynomial from this polynomial. Okay? So I have 1x cubed minus 1x cubed. That leaves me with 0x cubed. And then here we had no x squareds to begin with, but we're going to subtract an x squared from that. So this becomes minus x squared. And then we can carry down the remaining terms. So plus x plus 0. That is one step of polynomial division. If we look at what we've done, we've taken this divisor, we've taken an x squared out of our dividend, and we have a remainder. So after this single step of polynomial division, what we've done is we've found a different way to write down this original rational expression. So taking these pieces, we have all the things that we've divided out, which will be up here, and then a remainder, which still must be divided by this divisor. So after one step, what we've got is our original rational expression would be equal to the x squared that we were able to divide out, plus this remainder still divided by the original divisor. So we've said that x cubed plus x divided by x plus 1 is going to be equal to x squared plus the remainder minus x squared plus x divided by the divisor x plus 1. Okay, so that's one complete step of polynomial division. Usually you continue polynomial division until you end up with an expression which has a lower degree polynomial on in the numerator than in the denominator. So in this case, we'd usually keep going with polynomial division if we wanted to completely divide this thing out. Okay, so I'll keep going, but that right there was one step of polynomial division. Okay, so to continue, we repeat the process just like we would with regular long division. So we look at the leading term in our remainder, which is now negative x squared. Okay, and I want to multiply my divisor by anything necessary to match the leading terms. Okay, so I want to take this divisor and I want to multiply it by the right thing to turn its leading term, x, into a minus x squared. So what I'm going to do is I'm going to multiply my divisor by negative x. That'll match the leading terms, and it will give me the next piece that we're going to divide out of this polynomial. Okay, so now we multiply by negative x, and once we do that, we subtract, right, the polynomial divisor from the remainder that we had here. Okay, so I'm just going to subtract these two things. The leading terms cancel out. That leaves me with no x squareds. Then the second terms here, the x terms, are going to match up. So we get plus x, and then we're subtracting a negative, so that we end up adding one more x. So there are two x's. Okay, and there are no constant terms, so we still carry that 0 down. Okay, so after two steps of polynomial division, we've divided out an x squared, a negative x, and we still have a remainder. So right now, we have our original rational function, which was equal to this thing, is also going to be equal to x squared minus x plus this remainder, which only has a 2x in it, divided by our original divisor, x plus 1. So that's two steps of polynomial division. And we can go one more step and still have a rational function, a function with a polynomial in the numerator and a polynomial in the denominator. So we'll go ahead and do that. Now we need to match up the x and this term 2x. So if I want to match those up, I can multiply my divisor by 2. So 2 times our divisor gives us that, and then we subtract it. We multiply by 2, so we put 2 up here above the division bar to record what we needed. And then we do our subtraction. The leading terms cancel. 0 minus 2 gives me negative 2. So after this last step of polynomial division, we have x squared minus x plus 2 plus negative 2, that's our remainder, divided by x plus 1. Okay, and that completes the polynomial division. Right. Now, after this basic idea, just this idea of doing long division with polynomials, we can see that this comes out nicely in situations where the polynomial, we're trying to divide out a factor of a polynomial. So let me show you what I mean by that. I'll do another example. And this time, when we complete the process, there will be no remainder left. Okay, there will be zero remainder because we'll get something that divides in a nice way, divides in evenly. So as a second example of polynomial division, let's take x cubed minus x. Do that. And then I want to divide that by x try to divide, well, let's make it even easier. Let's divide that by x minus 1. Okay? So I claim that this is going to divide evenly. So when we finish our polynomial division, there won't be any remainder. We'll have a stage where we have zeros for everything in our remainder. Right? So let's go ahead and try this. And this time we'll do it a little bit faster. We'll do one step at a time, but we're just going to do straight polynomial division. So x cubed minus x divided by x minus 1. Our divisor goes outside. Our polynomial goes inside. X cubed, no x squareds, minus 1x, and no constant terms. All right, so to proceed with the division, we multiply the divisor by whatever is necessary to match this leading term here. So I want to multiply by 1x squared, and that will give me x cubed minus x squared. Then I subtract those polynomials, and I end up with plus x squared. Carrying this down, we get a minus x. Next, we have x minus 1. All right. So I think about what I need to multiply that by to give me an x squared term. I want to match those leading terms. So I can multiply by x, x squared minus x, and then I subtract. And here, the leading terms cancel, and so do these x terms. I have minus x, and a double negative there, so plus minus x plus x gives me 0. There's no remainder whatsoever, and I have this and this. Okay? So what we find is that this expression is actually equal to all the stuff we divided out with nothing left over, no remainder added on. So this is actually equal to x squared plus x. Okay? And now, to give you some idea of why that is, why that's what's left over, what we can do is we can look at what happens if we try to factor the numerator. By factoring the numerator, we'll be able to find that this expression comes out in a slightly different way. So if we do that, let's just look at this expression in another way without using polynomial division and see that the result comes out the same. So if we factor our numerator, we can first pull out a common factor. Each of these terms has one copy of x in it. So if we factor out that common factor, we get x times x squared minus 1. The divisor is the same. And then if we recognize that this is a difference of 2 squared, we can factor a little bit further. So we have x multiplied by x plus 1, x minus 1, to factor this difference of 2 squares, divided by x minus 1. And when we write this rational expression in this fully factored way, now what we can do is we can cancel out common factors that are shared in the numerator and the denominator. So we see a factor of x minus 1 in the denominator and the same factor in the numerator. And those cancel out perfectly, leaving us with x times x plus 1. And if we distribute that, we get to exactly the same answer that we got using polynomial division. So x squared plus x is equal to x squared plus x. Okay, so that's a second example of the basic process of polynomial division, but in a situation where the division is perfect, that the divisor goes into the numerator evenly, perfectly, without any leftover remainder. Okay.